Okay, so hi, I'm Dave. This is Dave Splains, and I just want to make sure that you understand that one, it really helps me out if you at least like the video, because if you like the video, then YouTube kind of gets this idea that other people might like the video. The video is likable, so you can just, make sure that you hit that button so that, I get out to other people who might actually enjoy the video and everything. And then over here, hit that subscribe button. I mean, and to be perfectly honest, you subscribe to me, you're gonna see the occasional video. I'm not gonna be in your face every day, except for I am trying to be that way. I am trying to do that in the month of November. Which means you might want to subscribe in case you actually do want to see a video, because I'm going to try to do, well, all that's in the announcement at the end of this video. So if you could just go ahead and like and subscribe now, that'd be great. And on to the video. Smiley face. Hello, YouTube. I am Dave, and this is Dave Splains. So, binary mathematics. The fun part is that I actually learned this originally in my first semester. I can make S's better than that. That's an R. Of my 2-year degree. And then I had to go through it again in my last semester of my master's degree. So I actually began and ended my education so far anyway with the exact same lesson in binary mathematics, so it must be important. So important that some of the research I did actually brought me over to the organic chemistry tutor, which I thought was interesting that also this is in organic chemistry. So the real thing that we really should start off with binary mathematics is that looking at this from electrical engineering, which is what I originally was in school for. I have an associate's in electrical engineering technology, which means it's the 2-year version of an electric. It's okay. Anyway, it's not exactly yeah. So the thing you have to think of is, well, let's just draw something that we're all pretty familiar with, and by now, and that is a switch. This is a panel switch, or a rocker switch is what it's usually referred to as, and we usually see them in homes to turn on and off lights. Well, the whole reason behind a rocker switch, by the way, is so that you don't catch your clothes on it or bump into it as much. So going back here, that switch in electronics is usually referred in this manner. So right now, this is an open switch. It's not connected. Usually there'd be like some kind of node there. So here's our node. And then this would be a closed switch, where, as you can see, if I put a node up here, you'll see a node on top of a node. This means that the signal is going through. So this is on, this is off. That's what I want you to think about when we're doing this. I'm just going to move this up here so they're touching. I'm going to make them a little bigger. Because inside of a computer you have your switches constantly being turned on and off inside of a processing chip. So there's thousands of these inside of one. So now that we have that part covered, in binary, everything is either on or off. On or off, that's it. And we usually do this in groups of 4. And anybody who, I don't know about PlayStation 4, but PlayStation 3 would, anybody who actually played like a larger amount of people in a group would recognize this on the controller. This is a really bad drawing of the controller, because on the controller, the player status would always be with these different lights. And you would have one light on, and the rest of them would be off, and this would be player 1. This would be player 2. Here. This would be player 3. This would, so just practicing here. This is our 1 spot, our 2 spot, our 4 spot, and our 8 spot. So equals 4. And then you would add 2 of them together. So I would do this, and then I would do this, and that would equal 5, because I'm taking 4 plus 1 equals 5. This is not the high level of binary mathematics that we're talking about. Okay, so I know what this looks like, and this looks like it's the math. This is not the actual math. This is just an understanding of how this actually works. Okay, after doing a little bit of thinking, you know what? I have been thinking while I've been doing this video, and I can't see where in data science, or at least machine learning, artificial intelligence, where this would actually come into play, because you can sit here and go back to the decision table that we talked about a couple of videos ago, where here is the descripting thing, like, will we go to the park? You know, and is it raining? Are there other, is there a lot of other people? Do they allow dogs? Is there a playground? And so we should probably take out raining, because this is going to be like a positive thing here. Is there a playground? Is there a little water park? I can't write all of this in my little thing here. And then this is going to be our weight table. Like, and for me, obviously, because I don't have a dog, do they allow dogs? It's kind of like on a 1 for me. I have kids, so I care more about the playground or the water park as if is it sunny. So I'm gonna put other. Is there a lot of other people down on 1, because I don't really care. Dogs would be probably 2, because I don't care, but I think dogs should be allowed in parks. Is there a water park? Would be like a 3. Is there a playground? Is there a 2? And is it sunny? Sorry. And then is it sunny? And that's just because sunny, you know, this is the weight that it carries. Again, I don't care if there's a lot of other people there or not. I also don't care if dogs are there. For some reason, I care more about dogs than I do people. I don't know what to say. And then, is it sunny? If it's rainy, all of this other stuff doesn't really matter. So that's why the sun gets so much more weight to it. And then we can go, okay, on or off. This is usually how it's referred to as O/1. Oddly enough, further on into my career, I actually started finding out that this is a slash, this is a whack. So thank you to my old manager for explaining that to me. So is it sunny? It is not currently sunny. Are there other people at the park? Well, if there's not sunny, the chances are probably not. Are there dogs there? Sure. There's a couple of dogs there in their cute little raincoats. Okay. Is there a playground? Yes, there is. Is there a water park? No, there's not. So currently, this out of a possible 15 only has a 6. And just to answer the question, we will not go to the park because it only scores a 6 out of 15. So that's one place in data science or machine learning, artificial intelligence, where you could actually go ahead and use that, this whole binary system, where binary mathematics might come into play. So, binary math. Let's get back up on my script here. When we're talking about binary numbers, and we're gonna go say 32, often it is referred to with a 2 subscript. That is, if I outline where the 32 is and then the 2 is halfway underneath, that is called a subscript. That is usually how binary, because it's 2. It's 2 options, on or off. So, with binary math, 0 plus 0, as in the real world, equals 0. 1 plus 1 equals 1, and then a 1 up to there, and then creates a 0, and then it goes to a 1 in the next column and then comes down. And in the world of binary, that is, again, 2. So if you ever want to sit there and argue with a teacher that sometimes 1 plus 1 equals 3, it's true in binary. See? 1 plus 1, 2 plus 1 equals 3. I just want to make that joke. I never have the opportunity. So, 1, I don't know why I did that. 1 plus 0 equals 1. 0 plus 1 equals 1. So on and so forth. Let's get to the math. This is often done with 4 bits. So let's get this rock in here. And we will do 12 plus 5. Now, 0 plus 1 equals 1, 0 plus 0 equals 0, 1 plus 1 equals a 0 with a 1 carried up here, and then a 1 plus a 1 plus a 0 will be a 0 with a 1 carried up. So this is 8, 4, 2, 1 places. This is the 16. So this would be 16 plus 1 equals 17. And of course, 12 plus 5 equals 17. So what happens in a situation where we have a 1, we have a 1, we have a 1. This did not work out as well as I had hoped. I don't know what I was thinking. So this is a 0 and the 1 carries over. What happens when we have 3 1s? Really simple. These equal a 0, and then a 0 and a 1, sorry, with a 1 carried over. And a 0 and a 1 equals a 1. Bring down that last 1 up here that we carried up. Carry that 1, and we have 1, 2, 4, 8, 16. So we have 24 here, and we have 3 here, which makes 27. Just to make sure, we have 8, 4, 2. So that equals 14 here. 8, 4, 1 equals 13. 13 plus 14 equals 27. Now what happens with subtraction? Can you see this okay? Is this going to be? Yeah, that looks good. So what happens when we have this scenario? Because you can't subtract 1 from 0. And for anybody who's wondering, like, how can you be sure because this is the 2's place? Well, I can be sure because 2 minus 2 equals 0. And you have to remember that little philosophy here is because this is the 2, here's the 1, here's the 4, here's the 8. That means that this equals 2 of these. So unlike our binary 10 or our numerical 10, where if you subtract a 1 from the 10's place, this becomes a 9. Now it's just a 2. That's all you have to really think about of this. So we have a 1 minus a 0, can't do it. We remove this. This becomes a 0. And this, now a lot of people, I've seen this written as 2 times 1. That is in the All About Electronics channel. The organic chemistry tutor will do this and call it a 2, and I don't like either of these two ideas. I think it's a little convoluted. We're already doing so much with our little tick marks here of on, so why don't we just write it as on. We'll change it to what it really is, 1 over 1. So we have 1 over 1. These two will cancel out because we're subtracting, and then we're still left with a 1. Okay, same scenario again though. What happens? We have to cross that out, tick, tick, and then this becomes a 0, and 2 ticks cancel out. Now we still have 1 left. Same scenario again. So we do cross that out. This becomes a 0. This goes tick, tick. There's 1 left over, and nothing left over here. 4, 3, sorry, 4, 2, 1, 3, 7. 14 minus 7 equals 7, and as you can see here, that was also our original. Here's our original 7. They match, boom. Now, there's a lot of fun with binary. I strongly suggest you learn as much as you can about binary and hexadecimal and everything like that, because it's always fun stuff. Check out like AND gates. AND gates are always fun, and they actually go into data science. They go into a lot of things, even referential stuff where you're Googling something and you want to include, I mean, because it's all logic. So these are called logic gates. So and, or, nor, and not, which is really fun because it's like on once it goes through the gate. It's like an arrow with a going into a wall, and it comes out as an 0. It's basically like sending your on signal into a wall. It's not going to go anywhere. But on the opposite of that, somehow it will sit here, and if it's off, it will be on when it comes out. So it's some crazy stuff. But going back into Google, if you were to Google something that had to be gorilla and silver, you wanted silverback gorilla or something like that, you would only get something that has this and this. And you would think that because you're adding two things together that it would be bigger, but it's not. And if you wrote gorilla or silver, you would get everything that has anything to do with a gorilla or silver. So you'd be getting results in Google about silver mines, and you would be getting the gorillas exhibit at your local zoo. So some fun stuff with that. And if you actually do that in Google, it's really fun because it's and, or, and a lot of this has a lot to do with going back into our into databases. I know that sounds like a stretch, especially since I haven't used the pink marker, so I really should have done that. So, I'm going to leave it off with that. I have a ton of editing to do now, and I'm going to go do it. So, I hope you enjoy this. And now I have an announcement for the back of this video. So, for all of you who have hung out to the end, I am going to try to put up as many videos of me actually writing code to do different projects from beginner to end through the month of November. I want to try to do a video every day. Obviously, November 11th is going to be my annual Veterans Day Veteran Story video having to do with helicopters. With that, I hope you enjoyed the video, and I hope I can edit it to a tolerable option. See you, well, it's the 12th today. Oh, I'm gonna hope to do another video this month, if not 2, and then Obviously, November is going to start. So, all right. Have a good one. See you in the next video.